download our Revise It Right revision app for hundreds of videos, quizzes, exam questions, tutor support and so much more. This video is about isotopes and nuclear radiation. Now, isotopes are atoms with the same number of protons but a different number of neutrons. Okay, so let me give you an example of what we mean by an isotope. Now, a very common isotope is carbon. So you have carbon-12 and carbon-13. Okay, now I'm going to draw both of their representatives underneath. Now remember what I said in their previous slide, that all carbons, regardless of whether being an isotope or not, all carbons have an atomic number of 6. If that were to become a different atomic number, it would become a different element, a different atom completely. Okay, so all isotopes have the same number of protons as represented here. Remember the atomic number, how many protons they have. Carbon-12 has 6 protons, carbon-13 has 6 protons as well. However, the mass numbers are different. So for example, carbon-12 has a mass of 12, i.e. the name carbon-12, and carbon-13 has a mass number of 13. Okay. Now, if we go back to what we were talking about on the previous video, if we work out the protons, as we just said, that's the atomic number here, so that's 6. Therefore, the electrons is also 6. Again, if you don't know what I'm doing there, please go and watch that previous video on atoms. But neutrons in the carbon-13, neutrons in the carbon-13 is 13 take away 6 is 7, and in carbon-12 it's 12 take away 6, it's therefore 6. So this here is an isotope of carbon. It has the same number of protons, but a different number of neutrons, and that is how we describe an isotope. So remember, isotopes are atoms with the same number of protons but different number of neutrons. Here is an example, carbon-12 and carbon-13. Atoms are radioactive if the nucleus has too many protons or too many neutrons. So for example, our isotopes that we just looked at. This makes the nucleus unstable. All types of radiation comes from the nucleus of the atom, and you cannot predict when a nucleus will emit radiation, as the process is completely random. We have 3 types of radiation. We've got alpha, which has a symbol like this, and it is a helium nuclei. We have beta, and it has a symbol like this, and it is an electron. And we have gamma, and it's a symbol like this, and it's an electromagnetic wave. Radiation can knock an electron off an atom and turn it into an ion. This is known as ionization. The ionizing power of a radiation source is how easily it can do this. Now, as we just said, there are 3 types of radiation, and I'm going to take you through each of those 3 now, what they're made of, their charge, their atomic mass, their penetrating power, and their ionizing effect. So, alpha particle, as we said, is a helium nuclei, therefore it's made up of 2 protons and 2 neutrons. Now, because of this, it has a charge of +2, and it has atomic mass of 4. Because 2 protons have a relative mass of 2 and 2 neutrons have a relative mass of 2, so that's an atomic mass of 4. In terms of its penetrating power, it's stopped by a thin piece of paper, or its range is a few centimetres in air. So it's stopped by a thin piece of paper, and it is a range of a few centimetres in air. And it's strongly ionizing. Now you'll remember earlier we said that ionizing radiation is radiation that knocks electrons off of atoms. Therefore, alpha particles easily knock electrons off of atoms. Now we'll move on to beta. Now beta is a fast moving electron, and we know that electrons have a charge of -1, and we know that electrons have a mass of basically 0, so we put 0. In terms of its penetrating power, it's stopped by a few millimeters of aluminium. So it's stopped by a few millimeters of aluminium, and it has a range of 1 meter in air. So 1 meter in air, so that it can travel 1 meter in air. And it's slightly ionizing. So not as ionizing as alpha, but more ionizing than gamma. And finally, we're going to look at gamma, which, as we said, is a high energy electromagnetic wave. So it's an electromagnetic wave. It has a charge of 0 as it's a wave, and a mass of 0 as it's a wave. Now it can be stopped by a thick piece of lead or concrete. And it's very weakly ionizing. So this is a nice table really to sum up alpha, beta and gamma radiation, and we have to remember each part of this table. So it may be a good idea for you to screenshot the page, or if you would like to take your own notes, then please do. But we have to remember these points here. So just to explain a few of those points, and as we said earlier, radiation can knock an electron off an atom and turn it into an ion, and this is known as ionization. Now, because alpha particles... Remember to download our Revise It Right revision app, watch over 700 videos, answer 4,000 plus quiz questions, over 1,000 flashcards, 1,000 exam questions, worksheets, forums, and get help from qualified teachers, and so much more. The link is in the description. Are the biggest, so when we draw our alpha particles, they are the biggest. They are Now, because alpha particles are the most massive and the biggest, they are the most likely to ionize an atom. They're the most likely to be able to knock into an electron and knock it off, i.e. they are the most ionizing, and that is because they are the biggest. Okay, so they're most ionizing because they're the largest, they're the biggest. And then of course you have beta, which is just an electron, which is only slightly ionizing because they have a size in between that of alpha and gamma. So they're not the smallest, but they're not the biggest. They're not as big as alpha, but they're bigger than gamma. And gamma particles, because they are a wave, they are weakly ionizing because they're not very likely to knock an electron off an atom because they're not very big, okay, compared to the size of an electron. Now, because alpha particles are the most ionizing and they travel... Now, because alpha particles are the most massive and they are most likely to ionize, in doing so they give up their energy and are not able to travel very far. And because of this, they are the least penetrating, as we said. So if I draw a piece of paper here, they can be stopped by that thin piece of paper. Now, beta particles are slightly more penetrating, so they will be able to go through a thin piece of paper, but they will be stopped by a thin piece of aluminium. And finally, our gamma particles can go through the paper, they can go through the aluminium, and are stopped by a thick piece of lead. So, just to very quickly summarise, alpha particles the most ionizing but the least penetrating, and gamma particles the least ionizing but the most penetrating. Now I'd like you to do is have a go at answering these questions here, and then we'll go through the answers afterwards, so pause the video now. Okay, then let's go through the answers then. So question 1, what are the 3 types of radiation? alpha, beta and gamma. Question 2, what are alpha particles made up of? They're 2 protons and 2 neutrons. Question 3, what are beta particles made up of? Well, they are a high velocity or a high speed electron. And what is gamma radiation made of? It's an electromagnetic wave. What is ionization? Well, it's when an atom either loses or gains an electron. And finally, why is radiation dangerous? Because it can cause body cells, the nucleuses, to be ionized, which can cause mutations within the cell, which leads to tumours and cancers. So we've now looked at nuclear radiation and the different types being alpha, beta and gamma. You can now test yourself using the quiz and the exam questions on the topic. If there's anything you didn't understand in this topic, then please do get into contact with one of our tutors who will happily help.